So I believe that if you have any experience with SQL, you must have gone through window functions for any other use case. Is it or no? No, that's okay. Hope you are good to see my screen, and let me continue with this. So a window function is actually, this is a very much required function in PySpark that you are going to use on daily basis. Okay. And I can say that if you are doing any of the, let's say anyone has used group by and all in SQL. What about you, Chandan? You have good experience with SQL, right?
Not experience, but we have SQL DB2. Actually, we are working DB2, so we have experience.
Okay, so about this window function which we are going to use in means we this window function we used mostly in SQL. If you are using in if you are using Hadoop, then in Hive as well. In Spark also this is, or any SQL like tool you are using, there you may get. I'm not saying 100%, but this will be along with the SQL, because this is these properties are coming with SQL only, which are going to work in optimized way with some different behavior, and this is going to give a one layer better solution comparing to your previous things. Like let's say you are doing group by or any other aggregation functions, then how that is behaving and how you can do the same thing with window functions and it will be behaving something differently. And again, there are some other things like you are having row number, rank, dense rank, lag, lead and all. These are the parts of window functions, and they are having some different properties that you are going to get. So these window functions are a powerful feature in SQL and data processing framework like Spark as well. Likewise, I said in SQL, they perform calculations across a set of rows related to the current row, allowing us to compute metrics without collapsing our data into a single row per group. If we break down, let's say we are having, if I am saying about window definition, then I am using over by, then I have partition by. Okay, so if we break it, then the override clause defines the window or a range of row over which a window function operates. We are going to define a range that this to this, I am going to apply this function. It can include optional partition by and order by as well. This is partition by. If we want to do only over by, okay, this is the range I want to do, that is okay. Again, if I want to say this is the partition by this column, and again if I want to do sorting as well, then order by this column. In that case, we can include this partition by and let's say order by. Okay, I have already kept here this order by clause. So order by I will not keep parenthesis because we give simply order by column name. Okay. And next, when you talk about partition by, then partition by clause groups the data into partitions for the window functions to operate within. Each partition is processed independently. Whatever partitions you are giving, if you are having one column for the partition, two column for the partition, or multiple column for the partition. For example, if I talk about this first one, let me take one simple thing so that will be clear for you. So let's say I'm saying select name, then city, then total, let's say some total value. So total, okay, let's say total value only. And we want some ranking, rank and over, then partition by. Partition by, let's say here we have name, city, total value, and now we are going to get the ranking. Means with rank, with window function we are going to operate this. Here any column we can take either partition. If I want to partition the data based upon the city, then let me take partition by city. Then again, we can have order by as well in the clause. So I can take order by, then total value. This is again one column, total value. Let's say I want in descending order, then descending, and next as rank in city. Okay. Then from your table name, let's say this is sales data, just assume sales data. So this is one of the query where you are going to use this over as we discussed, and then you are going to get partition by and city by. So it is going to process with the range for the data where data is partitioned by city. Then when we do partition by, then this clause is going to group the data into the partitions for the window function to operate within each of the partitions. And for this also, you can take the same query as your example. But again, if I can do little bit changes here, then let's say we are looking for average. So keep the same salary, select name, city, and let's say salary. Okay. And then I can say average. Let's get average salary. And then over partition by, let's say name. Here I will be giving one more column department, and partition by, let's say I want average salary by department as average salary by department from data. Okay, so like that we can go either by the partitioning or with the order or without order, and getting the rank. Here we were getting the rank in the city. Here I am going to get the average. Then order by, as you already know, we are going to sort the data either in the descending order or in the ascending order. So the order by clause specifies the order of rows within each partition, how many partitions we have. Okay, so let's say you are having 4 city, you are saying partition by city, you are having 4 cities. So for each one, there will be the ordering. So if we want to assign a unique row number to the employee within each of the department, just as example, then you can add and then sort by the joining date and then get the final output. In that case, you can run something. And again, you can keep in mind in the interview also, you will be having very frequent question about window functions. If you know, then you can discuss about rank, dense rank, ranking, row number, and all. So let's say you are having a column, select department ID, just as example, employee name, then joining date, then row number. This is again one of the window function, row number, which will be giving the numbering 1, 2, 3, 4 over, then partition by. Partition by, let's say department ID, we had the column with department ID, and then you can say order by. Order by, then let's say we have joining date. Then for each of the for each of the partition means for each of the department, this is going to order the data. And then if you want here, you can keep either descending or ascending. If you want descending, you can. Otherwise, if you are not giving ascending, then by default that will be taken. And then as, let's say employee rank, it will be giving the rank. Then from employee data. or employee table. Okay, so like that you can. Then we have frame specification. Frame specification we have for where a subset of row to include in the window using the options like we have row or we have range. Okay, so if you have just I am assuming that you are having some idea about SQL, then you there can be something row between this and this, like you are going to give some range. Let me take this one query only. In this query I will include that where you are going to give some ranging. So this is this one where you are giving average salary, then over partition by this column. Let's say I am not giving partition by, let's change this something, order by. Okay, order by department, and then rows, rows between uh, let's say, have you get any which case something like calculate the rolling average of the sales over the past 3 months, past 1 month, past 2 months or something? Okay, no issue, you can try it out, or I will be sharing the same in the exercise. So between let's say two, these are the keywords. Okay, this preceding and current. You can keep in capital letter for more readability. Current row. So this is for getting the kind of rolling average. Okay, rolling average of the sales over the past. We can have some kind of slicing. Okay, get this for 1 month or 1 week or 2 month, like that. Then we have common window functions, that is for the row number and your order by rank, dense rank, and lead, lag, and all. There is a very common question about the window functions that you may face: rank, dense rank, and rank, dense rank, and row number. So let me keep row number here. Row number, rank, and dense rank. This is a very frequent question in many of the organization you may get during your interview. So if I talk about row number, this is very common. If anyone is talking about, if you know the window functions, then you can talk about it. And if you are not remembering all the things, at least you can talk about row number, partition by, order by, and this rank, dense rank, and all. If you are talking about rank and dense rank, then there can be a question: what is difference between that? This is very common question. Okay, and even I can give you a company name. That company name, if you are going for, if 10 people are going for the interview, I can say that out of 10, 7 are going to get this question. I don't know, either they have some generic questions or what. Uh, Coforge, right? NIIT. What about the company name? No one.
Yeah, previously it's NIIT. Now it's Cockroach.
Hmm. So this is very favorite question for them. Okay. I have seen with multiple people. They very frequently get this question. Okay, so if we talk about row number, then this assigns a unique sequential integers to row within a partition. Within a partition, let's say you are having department ID. You are saying partition by department ID. You can have multiple department ID. You can have financial, then you can have sales. You can have your customer for the customers means, or let's say you are having debit, credit, and all. If that is the banking related data. So how many department you have? If you are working for the IT side, then IT, software, hardware, you are having admin, HR, and all. So multiple department, there will be multiple different employees, employee ID, and all. And for each one, this is going to generate a sequence number. Okay, so this is going to do within the partition and not across the partition. This we have to take care. So this is going to assign a unique sequential integers to row within a partition. If you are having two partitions, let's say one is finance, one is IT, then for IT there will be separate sequence. For finance there will be separate sequence number. And use case for this is there can be a use case. Let's say that you have the question, find the most recent transaction per customer. Okay, per customer when it comes, then you can go for row number and you can do with that. How you can do with that? You can say, I believe that you have gone sometimes with CTE in SQL, where you can write a query like this. Let's say I am writing with the with, and then I'm trying to get the rank, then rank, and let's say transaction. I am just trying to get this for each of the customer. Then within bracket, I can define select ID, customer ID. Then, okay, let me write it, customer ID, then transaction date, and then row number. Here we are going to get it. Row number, and then over partition by. Partition by customer ID. Then this is going to get the data. This will be first partitioning the data based upon the customer ID, and then this will be creating the ranking for that. Then even I can say order by because I need a sequence. So I can do based upon the customer ID or transaction date or whatever we are looking for. Order by, let's say transaction date. And then I can give in descending order for better. And then I can say row number. This will be my column name from table name. From table name. And then here we can say again, this is our most outer query. Select customer ID, then your transaction date, and then not required. We need two only, right? Because the question is find the most recent transaction per customer. So recent transaction we did for the transaction date. It is when it will be doing with the descending order, then we will be getting for the descent date only. And then customer ID. We need only customer and date wise data. Then that is okay. From here we created this function. We can take this from this city and from where let's do this because here we created one row number. We can take it where row number equal to 1. Then this is going to give most recent transaction. Okay, so if question is get the most recent transaction per customer, then you can write something like this. Likewise, you can have some different question, but pattern can be same. Okay, so this one you can do. Let's say now you are having some rank. So assigning a rank to rows with gaps if there are ties with gaps and without gaps. That is different between rank and dense rank. So for this rank, I can say, let's say you are having example, rank the product. If you are having multiple product, then if you are going to sell that, there can be a condition where same product is going to have with same ID or same ranking or same number for the selling and all. So rank products by sales volume within each category. So there can be a possibility that that is going to be with the same volume for one than more product or more than one date kind of. So for that you can say then I will give you the example with the output as well how this is behaving. So let's take select and then category ID. So let's say this is your product category. And then you have product name, and then you not needed. Two things are okay. Then let's take rank. And for rank, we can say over. And then you can take again partition by. Partition by, let's say we want to get the ranking for category wise. Category ID. And then we can say order by cells. Uh, or let's say we are having one more column in the real time. We have category ID, we have product name, then we have like volume as well, how much selling is happening. So let's say take this as this name only, sales volume. This can make more readability, descending. And then let's take give a name. Let's say sales rank. Okay. And then from table name, from product table. Then this is going to generate the rank, and this rank will be having the gaps. I will show you with the output. And then you can have a dense rank. So if you are talking about dense rank, then your query will be almost same. Let me copy this. Select let's say category ID, product name, then you are having a dense rank here. A dense rank, and then over order by, you can give something let partition by order by, or you even this is not always mandatory that you are giving the both. Maybe you can have something else, something else itself, and then you can save. Then you have lead and lag. Lead and lag is for accessing the data from a previous row in the same result set, or getting the data from the next row. So lead is for, if we talk about here, if you come to lead, lag and lead. So lag is for accessing the data from a previous row. Like if you are getting the data for, let's say, weather forecasting, then what was the temperature yesterday and what was day before yesterday, like that. So if you want to access the data from the previous row in the same result set, you do not want a different result set in the same table, in the same output, you want from the previous row. Then you can use lag. Okay. And for the lead, if you want to access the data from the next row in the same result set, that what was the next after this row, then this will be next row, this will be the previous row. Then some average, max and min. I believe that you know this very well. These are your kind of mathematical function you are going to or aggregate function, you can say, in SQL, where you are going to do with the sum, with average, with max and mean and all. So let's take this with example. Here I have created another window function. Here if you come, I have taken this. I am going to do with the row number, rank, dense rank, lead, lag, sum, average, mean, and max. This much I have imported. So we are going to do with this. Okay. Then I have did the import with for the windows. Now just creating a Spark session, and this is the data. This data belongs to some department, IT, HR, finance. So this is employee ID, very first one. This one is the name, employee name. This is the department. Next one is salary. And then this is joining date, when they joined. Now creating the data frame. This is the syntax which is returning as a data frame, and then employee.df dot. So let me comment out the entire thing. Okay, and run this. Okay, so this is just the raw data frame which we have with the data. Okay, data frame is created. Now on top of this data, you can do the ranking and dense rank, row number, order by, partition by, and all whatever we are looking for. At the very first, I will be going with the one of the same simple example, adding the unique row for each row using row number. You can have a requirement where you want to add a unique row number. Here in this example, we are having this employee ID, and employee ID is something 1 2 3 4 5. So uh, don't care about it, because it will not be like that. This will be never sequence number. Okay. So let me do it for kind of 1, then 2 3 4 5 6 7 8 9. Now let me run it. Okay, so now this is the employee ID, name, department, and all. Let me uncomment this part. This is for so I will be adding this one. Okay, let me run this first, then we will go through it. So if you see, this is the sequence row number 1 2 3 4 5 6 7 8 9. This is creating one sequence number. Again, this is not having any partition by, let's say if I have the partition by department, then for each of the partition, this will be creating the sequence number. But I have not created with the partition by, means any of the column partitioning the data. I have just created row number for the entire row in the data frame or table, whatever you want to say. So if you want to create a sequence number like that, then you can. I have did I have created one a window specification for the entire data frame. It means no partitioning. There is no partitioning required, because I want to apply on each and every one in the sequence. So I'm just saying window dot order by employee ID. Okay. And then means based upon the employee ID, you need any column for the reference, right? And then employee ID with sequence df with column. I am adding this new column. You can have any column name, and then row number. I am simply taking row number over and window this specified specification window what I have given here. So either you can give this one this keyword or whatever we created, or simply you can use this one as well if you have not created it in advance. But this is good if you can create here, and then we can call it, because in this way you can do reuse it, means you can reuse also whenever it is required. And maybe there can be some other requirement as well along with this. There also you can be using, or this can increase your code readability and all. So this is better. Now we are doing the display. Again, if you do not want to do with the row number, then in Spark we have one more option available. You can avoid simply window function, because here for using this row number you need this window specification. Once you are doing this, then you are using this row number and you are getting the sequential number. Alternate you can do. How you can do? You can do with this one. Let me do this. Okay, so here let me comment out. Now I am taking this one, a row number, monotically increasing ID. This is dedicated for creating sequence number only. Just I'm creating a temporary DF. In this temporary DF, I'm creating one temporary ID, and that temporary ID is taking this. This is calling this function. Now window spec no order. Okay. Then I'm just taking order by temporary ID. So this is helping you one thing. You are not going to call your let's say you are not having any specific column here. If you see the differences here, we are taking it based upon the employee ID. What if you do not have such a column? Sometimes what can happen, you are having a single column only, and you are not having more than one column. There you want to have some indexing and all. So you if you are having the column names, you can take out. If you are not having, then you can create the temporary id, and based upon the temporary id you can create your function. Means you can call this. So here simply I'm creating one temporary id, and then defining a window specification with this, and then you are taking this id, and again here I have just given a name, and then you are calling this one. Let me paste this one also just to show you something. Temporary df dot show. Yes, then I will be having two data frame, and I will comment out this one also to avoid multiple outputs with no order. Okay, now let me run this. So if you see this temporary id, it has created first temporary id with this where it went here, this one monotically increasing id. So by default this is taking some random numbers in back end, right? And this is getting started from 0 0 1 2 3 4 like that, but we do not really need it. We are looking for the sequence. So first we are getting its by default nature whatever with the temporary id, and then based upon that temporary id we are creating a sequence number, and we are getting it. Okay. So like if you do not want to do that, then you can do simply with the temporary id also. And if you will be doing the ascending or descending, then you will not be getting this much number. If you are doing ascending or descending, you are going to, let's say we are saying ascending, then 0 1 2 3 4 5 6 like that you will be getting. You are not going to get this much. Okay. Then okay, so you can use any option. Either you are using this monotically, and or you are using this row number. Is it okay? Any input here? No.
So basically, a column we will be using temporary just to add a value. So we use that in SQL. So yeah.
Yes, this is just for adding a sequence number, because in real time you are having many, not many, 90% of the requirement where we need rank number sequence number as well, right? So either you
Yes.
can use simply row number, or you can go with this Spark function, which is normally for generating ID only. But this starts from 0 1 2 3 4, but you need with one. Then you can have some manual intervention, and you will be getting that.
Okay. Good.
Then you have, now let's come to your original one. What we were talking about this window function. I have called out each and everything in the same. If you see here, I have created one window specification, partition by department. I want to partition the data with department, then order by employee DF salary. Means order by any salary. Here just I have already data frame created. That's why I am taking this column name. If that is SQL directly, you can give the column name here. Then descending order. What will be my structure of output? I am going to get employee ID, name, department, salary, and then row number. With row number, I will be getting the row number. You can see how it is displaying the output. Then with rank, you are going to get the rank. Dense rank, you are going to get the dense rank. Now you can see how this is difference between rank and dense rank. And then lead and lag. Okay, lead means next highest salary, and lag means previous highest salary. Lag means one previous row, and lead means next row. Next row from the same data set. Let me run this. Uh, So this is result df. Result df dot show. Then I want truncate equal to false. You know why truncate equal to false, right? If you want the entire data, entire string in the output, if you do not want to truncate anything, then output is like this. So let me copy this in the notepad. Okay, if you see here, this is the employee ID. This is name, department. Now finance, HR and IT. This has been ordered. Okay, and partitioned as well. Salary. Row number, we have partition by department. So finance 1 and 2. If you look out this two row only. If you look out this HR, then this is doing the partition by HR. Then 1, 2, 3. That means this row number is not unique, right? This is unique for the department wise partition data, not for the entire row. Like previously we created row number, sequence row number that was for the entire row 1, 2, 3, 4, 5, 6. So that is different thing. That is just generating a sequence number that you can generate as per your need. But here row number is different. This row number is coming with the partition by department. Similarly, rank. If you see the rank, this is 95,000. This is 75,000. Then 1 and 2. Again 1 and 2 and 3. Okay, 1, 2, 3, and for IT, 1, 2, 3, 4. You look here, what is there? 1, 2, 2, and 4. What you see here? 1, 2, 2, 4. 3 is missing, right?
Yes.
Why this is missing? Because of uniqueness. This is creating the rank, okay? And when it is creating the rank, then this will be having the gapping. How gapping? This is,
Oh,
let's
it
say
means
90,000.
revision in case
Ah,
of
so
rank. Yeah.
So for both two employees, salary is same 85,000, 35,000. So for both of the employees, this is keeping rank 2. And then this is skipping the rank 3. And the next time this is going for rank number 4. Means this is thinking that, okay, how many employees are there? As number is same, keep it with the same rank. But if it is indexing internally, then 1, 2, 3. That means it is thinking that, okay, I have done for 3. So next will be 4. Not 3. So this is means this numbers will be coming with the gaps in the rank. Okay. And then look out for the dense rank. For the dense rank, for this finance, we are seeing 1 and 2, 1 and 2 and 3. For the HR, this is fine. Again, for same example for dense rank, 1, 2, 2 and 3. This is the difference between rank and dense rank. This is very frequent question in the interview, so you can keep in mind. Okay. In ranking, it will be generating the rank, but there will be the gap. If any number is kind of duplicate, then that will be internally that will be getting count as a sequence number, and in the output that number will be missing, that will get skipped. And here it will be the same 1, 2, 2, and then next time it is an maybe there can be more number with the 2, with 3, with 4. There can be duplicates. In that case, how many are same number? That is going to assign the same rank, but this is not going to skip any ranking in between 1, 2, 3, 4, 5. This will be getting continuously for any number of employees, any number of records. Okay, and then see the lead and lag. So this is the next highest salary and this is previous highest salary. what happened for the next one and previous one. If you look out the salary, this is 95, this is 75. This is the next salary, next row, right? So for Sunita, current salary is means for Sunita row. This salary is coming with 95k. 95k. What is the next row? Next row is 75. So this 75 is going to populate here. Now you are getting null. Why null? Because there is no next row for this partition. Partition by department ID. In department you have only two. So when it is ending means there is no next row, then you will be getting null. Again same for HR. For 2 you are going to get 65, then 60. For second there is no next row, so you are going to get null. Similarly for this one as well. So this is 85, 85 next row, and then 80,000 and then null. This one is just opposite. Okay. This is looking for the previous one. Okay, for the previous one before 95k there was nothing, so this is getting null. Again for the department HR before 70k there was nothing, so this is getting null. So lead and lag, in one you are going to get the previous one and in one you are going to get next one. Okay, like that you can go with the row number. These are the main functionalities within the window functions: row number, rank, dense rank, next, highest salary, and previous. This is just an example: highest, next, and previous. This is simply you can understand getting the previous row and getting the next row value. Then differences between rank and dense rank, one thing. And in most of the time you may get some interview questions like okay, get the top 2 employees from the company department wise. Same you can do in multiple way. Let's say you are doing with the normal query, group by and all. But you can replace the query with window functions as well. Okay, and that will be more optimized. Question can be there: if you are doing with the group by, then how you will be doing the same with window functions, so that you can do the practice, then you will be comfortable to response. So here if you see like this is going to create. Okay, and then let me run the next one. We'll comment out this. Okay, then again I am taking this anyway, this was not required, I have already created above. Okay, and then department, employee ID, name, salary. Then I'm simply calling sum, average, mean, and max, because these are also part of your window functions only. Okay, now let me run this. This in result df. Result df is not required. I will be calling out this one directly. This aggregate one. And for this is the window function result. So if you see the total salary, this is for sum, this is for average, this is for mean, and this is for max. Again, this is department wise. Okay, because if you look out for the minimum salary, then minimum salary is 75k only. But why this much number? This much number because for finance, this was the minimum salary. For HR, this was the minimum salary. For IT, this was the minimum salary. So if someone is asking, okay, get the minimum salary department wise, then either you can do by using group by, or simply you can do with window functions as well. So like that you can use, where you have to first define this window specification. Even directly also you can apply it, but this is good if you are separating this. And then you can call out over your data frame column. You can do this. Then this lead, lag, rank, tense, rank, row number, and all you can create accordingly. Okay, hope this is clear. I will move to next. I will just it. Okay. Now then this is the another transformation apart from group by sorry, this window function. So this is group by key and count. For group by key and count, you are going to group the data and count the occurrences in the data frame. Okay. Any question so far before moving to the next one for this window function?
No.
Okay. Let me uncomment the data because we need the data. This is TF. Okay. Then first let me run this to capture the data, original data. I have not printed it. df dot so false, blanket false. Why? And should we? This n means number of records, how many records I want to print. So I randomly gave number 20. So this is the original data set. Let me copy it. Then this is the grouping. Group by country and then get the occurrences for the value, whatever value it is having. Then simply you can call out to group by and count. If you have to write a simple query, then what you do? You can write if you are working with SQL, select a star from or select let's say ID, name, salary from table, and you are doing some, let's say you are applying some aggregate function over there, some counting and all. So let's say you are doing some max or mean something. Then here you are going to apply group by and then your remaining column names like that. This is your simple Spark one. But here simply in the data frame with the data frame API, this is already defined. If you are calling this group by, then it is going to understand what you want. And data frame dot group by, simply you can define the column name. Then based upon the column name, this will be grouping the data. And then finally you can get the count, whatever you want. This is the different thing. Okay. So like that you can do. Now let me, but again, group by. Group by means what? This is a global operation for the transformation whenever you will be calling the group by. Then if data is distributed amongst a number of nodes, worker nodes, then data is going to be travel between the nodes. If you are having two nodes, then between two nodes. If you have multiple nodes, then amongst all the nodes, data is going to move out, and this will be a costly operation. Okay. Let me run this. Then you can see the output. India is having 3 and USA is sorry, India is having 5, 3 here and 2 down, 5. and USA is having 3 count. So total count you are going to get using group by. So simply this did grouping by country and then getting the count. Fine. Next, if you have, but we can avoid whenever possible. We can check out if that performance is very costly, and if we can have some alternate. You are always good to do that. Then you have another transformation. Map partition with key. Okay, this transformation get applied on a function to each partition of a key value RDD. You are having RDD, you can have multiple RDDs, and all the RDDs can be maybe the normal RDD with the normal data, or it can be key value pair RDD. So this is for wherever any of the transformation which is coming with the key, this key, that means that is going to applicable with key value pair RDD, not with any random data. Okay. Then here I have created one of the RDD with some key and value where this is you can assume key value. Then converting that to just doing the map, creating key value RDD with the country H key, and then process partition function to process each of the partition. Process partition, this is the function. Inside this function I'm calling this parameter key and value in the partition. What is the length? Then going to get that, and then finally based on RDD also we can call the group by. If as this is key value pair RDD, so directly group by will not work. If we are having group by key, you can call group by key and then map partitions. With map partitions, we are going to take it. So you are having means again for any of the use case, there is nothing like you are going to use this transformation only. If you see you are having 50 transformations, 70 transformations and all, you can use in combination and you can use different transformations for the same use case in the different way. This is completely up to you. Once you have the understanding, then you can do that. So if you see there, just I am doing this is map partitions by key. Let me copy the output itself here for better understanding. Otherwise this will confuse. If you see 1 minute. Okay. I think this is going to be a bit complex, right? Because this is not coming with key and value. So let me do it like this. This is going to get the length. So let me print this one. Already one. Okay. So this is 500, then country India, product A sells 500. and then 300 country India. This is the RDD one. Okay, here also we can see. This is India 500 cells, then 300, then again 500, then 400 USA. Okay, so here this is printing the RDD. Okay. So simply we converted this data frame to RDD, created key value pair. We are taking row 2 as the key, then printing the RDD, then partitioned by this one, this one, this one. Okay, now when we are getting this, this is where I was confused because wrongly this data is still here. I should have deleted that. And if we check out this output, then 101, let me copy here. 101. This is the one time, right? 500 two times, 400 two times, 600 one time, 300 two times. Okay, so this is correct only. Okay, so like that, this is doing the map partitions with key. But here you can see instead of this data, means either you can have your manual data if you want to create, that is okay. This is very simple actually because you have only key and value. But if you are converting data from to RDD, then you have to define which is going to be key and value. Here we are going to get this second one, 0, 1, 2. This starts like that. So 0, 1, and 2. So this is the 2. This we are going to get as key, and then based upon that, you are going to get the sum, get the count. So you can have the indexing here. If you are not getting, if you are not having multiple columns, or you are not converting the data from to RDD and all, and if you have very simple data, then you are good to go with the default one that will be working out for you. Okay. And then there is a select expression. This select expression is what we are going to use on your daily basis task, I can say. Select the columns using SQL expressions in the data frame. Where select expression, product, country, sales plus 5 as sales plus 5. Here you have two things. One thing is, let's say you are having a data frame and you want to change the order of the column. There also this select expression can work because here product is coming like this. Let me just do the copy paste. So let's say product is here. I want product here. And I do not want sets. Means kind of select a statement if you want. And this is just a manipulation. Okay. Where I want to have this new column sales plus 5, and that will be my sales value plus 5 data that I can. For this, what you have the alternative. Anyone can tell for alternative for this operation. What will be if I am not doing like this, but I want to have a column that will be having plus 5 to the original number. What will be there?
Increase the count by 5. I'm not sure.
No. I am saying that I want to, let me write. Need to get a column cells plus 5. Cells plus 5 with some value. How you will be getting if you are not using like this? if you are not doing this with select expression, then how?
No idea.
You know, with column?
Yeah, just to give a ls name. Yes.
No, with column. Let's say you are having the data frame date, then you can say with column, and here you can give the column name. Let's say this is the column name, and then you can. This is wrong. This is the column name, and then you can express your logic how you want to get the value for this column. So either you can do like this, or you can directly go with this select expression only, and this will be much optimized than this with column. Okay, let's run this both. So if I am going here, what you get? If you see, this is the product, then country, then sales, then plus 5, 500 plus 5, 505, right? 305 and 505, 405. So this is simply doing the plus 5, and even you are doing without having with column. And here, if you see, product has been the second column. Country is the first column now. So if you have any requirement where you want to change the order of the column, you can use the select expression. You want to select some specific columns, you can do that. If you want to ignore some columns, that is helpful. And if you want some new column also with some other declaration, some means maybe some manipulation is there, you can do that even without having with column. And the thing is, select expression is mostly used to select and transform columns from a data frame using SQL expression. Simply like SQL you can do. It can create new columns, rename existing ones, or apply transformation. You can use for multiple purpose. Okay. And the main thing here you are going to get this takes SQL like expression as a string, and it can perform multiple operations in a single step, like creating, selecting, renaming, etc. Then returning, it will be returning a new data frame with the selected column, whatever you have. Like here, I had selected only 3. I had selected 2, and this was the derived column. And this is most suitable for the scenario where SQL syntax is preferable for the transformation. You are compatible with SQL and you want to do everything like that only. Okay. Then like here, let's say just a simple example, you are doing like this. Let me write one query. I'm saying data frame df1 equal to df. This is my original data frame. Then select expression. And here I just want to do some different thing. So I'm saying name as employee name, means I want to rename that. So I have with column and column renamed. We have options for the data frame level like with column, but we just want to ignore that. We are simply doing with the SQL kind of query only. Then let's say another column salary. Salary, then do some multiplication. Let's say 1.5 something as updated salary. That means you are good to do multiple operations with the same. Okay, that is going to help. Let me comment this, otherwise this will fail. Now you are having with column. With column is mostly used to add or modify a column in the data frame. Same like for this this updated salary also you can use with column, and for this you have option to rename the column. Okay, that you can use. So like if you have data frame df dot with column renamed, you have option. Okay, so either you give this, means first you define the new means whatever you want to change, and then what is the older column name. That using that you can rename or simply with the, if you go here, what it is asking? It is asking is existing. First, give the existing whatever the column name, and then what new you wanted to return, that you have to give. So either you go with column renamed, or you can simply go with this SQLite expression. So this SQLite expression, I feel that this is more easy and more handy. That's better. But again, this is up to the developer for what you are liking and what you want to use. So with column is mostly used for adding or modifying a column in the data frame we have, and it works column by column, creating or updating a single column at a time. And because of that, that is not optimized as select expression. That can be more better because that is not going to perform for row by row, and this with column is going to work by column. If you have multiple columns, let's say here you are talking about employee name, here you are talking about salary. So this is going to work column by column for the creating, updating, and this will be doing a single column at a time. It creates or updates one column at a time, and it requires columns transformation. And again, let's say you are having multiple column to add. So in this select expression, you can add multiple columns at a time. But if for the with column, you have to do df dot with column, let's say column A. Then you have to do dot with column, and then column B. So multiple times you are going to define that with column, single columns. Here, all the columns you can define in a single string. That is okay. So this requires column. This is going to create or update one column at a time. So for each one you are going with column separately, and it requires column transformation to be expressed using PySpark API, and then it returns a new data frame with the added or modified column, whatever you are defining with the with column. And this is useful when we are looking for step-by-step transformation, or when working programmatically with the Spark function, and we are not using this SQLite and all, then this is okay. Okay. And so this is the main thing. And based upon the use case, again, we can uh, use it. But whenever we are working with this, then optimization is the key part. We can always think which is more optimized and which is I can use. So this select expression is means okay. So let me tell you one thing. If we are talking about performance wise, the select expression or with column, both are having some pros and cons, right? This is not like this is good and this is bad. So if I talk simply about select expression, then this is optimized for multiple transformation at once. Whenever you have multiple transformation, here you can see, here you are having one plus. Again, you can have some multiplication as well. So let me do that. Here I am saying cells into 5. Okay. And simply I am saying multiply by 5. So like that, we can have multiple transformations. So if we are renaming, creating, or applying transformation to multiple columns in a one step, select expression can be faster because it processes everything in a single logical query plan. Then internally, what is in Spark, it is going to work with the logical plan. For each and everything, that is going to create the DAGs, logical plans, then physical plans, and then it is going to process with the steps for each of the transformation, for the different stages, for the different tasks created for each one, for each of the stages. So as here for the entire query, if you are having multiple transformation, multiple column addition, multiple renaming, for each of the thing, this will be having the single logical query. And if that is working for the single logical query comparing to multiple, of course, this will be faster. And when the logic is expressed in the SQL syntax, Spark can optimize the execution plan as well more effectively for the complex query. If you have too much complex query, then again you can get some Spark level optimization. But again, some issues are also here if that is having some benefits. If our expressions are overloaded, complex, or include heavy computations, there can be, let's say you are giving 10 plus transformation in a same stream, then of course there will be some overload. So if there is that is having the heavy computation and overloaded, then performance might depend upon the Spark ability to optimize the SQL plan. Not like how you are getting it smoothly, then it will be based upon the complexity and all, there can be changes. And if you are working with column, then this is single column operation. This is simply here you are going to apply multiple things, but with column you are going to work with single column only. When we are working with one column, then it is okay. If when you are working with multiple column, then you have to repeat the same with column, and that is often straightforward and performs well. Again, that is for the more readability, more straightforward. And if anyone is new also, that can be good to understand. And whenever you are working for the concatenation, getting the column level functions, literal value and all, with column is good. And this with column call creates a new logical plan for every query. If you are having 5 columns with 5 with column option, then for each one this will be having a new logical query plan, which can lead to inefficiencies if we have applied multiple transformations subsequently. So if you are having multiple, if you are having 1 2, then okay. But if you are having, let's say you are going to add some 10 columns, 20 columns, and 10 20 times you are going to add the with column, one thing you are going to do lots of coding, minimum 20 lines for the 20 new columns, 20 logical plans this is going to create in the backend. And by that time this is going to work for the column by column, then of course this time taker, it can be time taker. Okay, so the some differences you will be getting between the select expression and with column, but again as per your use case, as per your requirement, you can choose between both, which is better for your use case. And then you have repartition. I believe that repartition we have discussed already, repartition and Coalesce, right? For the repartition, simply you have data frame dot repartition, and this is going to increase the partition. What is the partition for the data? So by default, your data can be with the defaulted partition based upon the chunks of the data uh, with defined block size internally. And if you want to have some defined partition number, then simply you can use repartition. So this is just a repeat to our previous operation, previous transformation, repartition and Coalesce. So this is get partition, get number of partition is 2, because we said repartition 2. If you are saying repartition 10, then that will be working out. Then you have replace. This is one another transformation. Replace is for replacing a value in data frame based upon the specified criteria. So let's say here you are having a replace DF, data frame. This is our actual data frame. Then replace India with name this, USA with United States. If something null, then do NA. Then subset country. Replace DF dot. So if you have anything where you want to replace the data, replace the value, existing value, then you can do this. Okay. And here we are having this Bharat, United States. We did not had anything null. Let me do null in the original data. Let me say here null and f, let's say 0 0. Run this. So for null, this is replacing NA, right? So like that, whatever we want to replace, we can use this replace option and we can replace the value either for the single or for the multiple. Here we are taking care for all three, for India also, USA also, null also. If you have a single one, you can go with that. Which means n number of replacement you can do with a single. Okay, you can have you must have used a regex replace regular expression. Actually, a regular expression is much costly, but even you can use that as well. That we use for the replacement for the specific value based upon the search. We do the searching and then we do the replacement. But this one also you can use wherever it is suitable for the requirement. Most of the time in the real time, maybe this is not the requirement, but this null is often we get from the input data, and most of the time we have some requirement. Okay, if data is coming as null, then keep some default value instead of null, just populating the null. So in that case, you can have some replacement and we can use that. Then you have distinct value. So this distinct value is for removing the duplicates rows in the data frame, where you have simply to call distinct and drop duplicates. Okay, so this is the distinct df. You have to see this. You are simply calling distinct and the distinct df dot show. Let me keep it in the same order. Okay, and then drop duplicates. Then you have this option drop duplicates country, and then let me print out both and you see what is the difference between distinct and drop duplicates. Okay, this replaced df. I should comment out. Okay, so here if you see country, I have did print for single one only, distinct df, drop duplicate df. Let me check this is coming for which one, because I have the select expression dot show also multiples are there, so sometimes this is not clear. Okay, let's do this. I will comment out this as well. And now this is okay. And then I will be printing one only, distinct df dot show. Okay, so this is the original data frame. Then this is RDD1. RDD1 is again a print here. Print RDD1. And after print RDD1, we have number of partitions not needed. Okay, now let me run one more time. Okay, now I will copy this output. I will just show you. Okay, India, And again India, null USA, ABC 400. Let me duplicate some data. There is no duplicate, it seems. So I will be doing India A, again India. Let me copy this. Okay, now I will run this. Let me copy this one only. This is the output. This is India 500, 300. So I had given India 2 times A, right? Duplicate. But that is not in the output now. This has simply removed the duplicate data. Okay. Here, if you see A, you are getting 2 times, but here in the output, this you are getting single time only. That means if you are doing drop duplicates, sorry, distinct, you are getting distinct, right? Not drop duplicate. Yeah, you are getting distinct. So whenever you are doing the distinct, simply this is checking for the all columns, not for the specific column. Based upon all the columns, this is simply doing a check if anything is exact duplicate for the entire row, and if so, then this is going to remove that. That is with distinct. And if you are calling drop duplicate, then for drop duplicate, let's say you are doing based upon the country, then here is the difference between both. If you do this, then this is giving, this is the output. Then based upon the country or based upon the any column. Here in the example, we have example with the we are getting the output based upon the country. You can say based upon the product, based upon the sales data, sales amount, volume, salary, whatever you have. So then this will be checking duplicate based upon that country only, based upon that salary only, department only, not for the entire key column, entire columns, entire rows and all. This is not going to match. So if you are doing the drop duplicates, then you are defining a column, and based upon the column, this is going to find out the duplicates, and this will be removing. If you are doing the distinct, then it will be checking for the entire column, and based upon the entire column, if any row is having the exact match, then that will get removed from the output. Otherwise, if any of the row is having some different value, then that will be existing. It is not going to be removed. Fine. Then you have drop duplicates. This is the above one only we did. Okay. Drop duplicates. And let me comment it out. Then we have describe. What is described then? Let me comment out this as well to avoid too much output. So this describe is for cells. Cells is the column name. This is going to compute summary statistics for numeric column for a data frame. But this can be done for the numeric column only, not for any other column. For example, okay, I will show for names as well. For let's say for the sales data only. Sales data is the numeric column. Then I'm saying description df dot show. Just we have given the describe. And here you can see this is the summary. Count, mean, max, okay, mean, max, average, whatever it can have. So this is giving a stats. So if you want to get the statistics, you can go for that. And here that is the non-numeric column. I am simply taking this and I will be commenting this. Then let's see. What is the output? This is saying this cannot be resolved because a column or function parameter with name cannot be resolved. Did you mean the following? Sales, country, product. This is saying that maybe you missed something. And uh, this is the unresolved column. Okay, so this is returning with the analysis exception. That means it is not good to understand whatever we are calling out. We are saying to do the describe, and this is the string, this column is having a string value, but this is looking for a numerical column. That's why this is not good to perform this operation, and this will be failing. So if we have something where we want to get statistics, we can use this describe. Then we have transform. If you look at this transform one, then sometimes you can have a SQL query if else condition, like when this column is this, then do this, else do this, like, right? Or if this is the condition, then this, else this. In SQL, we have very frequent that kind of requirement, that kind of query writing. So here for the transform, I am writing a function, add country code. Here as an input parameter, this is going to take a data frame. What it is going to return? This, if you understand from this function name itself, this is looking for a additional column which will be country code, and that will be having the value. So return df dot with column, then country code, when column equal to India, then country code is in like that. You can have multiple condition, where here I have single you can have multiple when country equal to India, then in, when country equal to United States, then USA, when country equal to United Kingdom, then UK, like that. You can have multiple conditions. Otherwise unknown, if there is no matching country name, or maybe some other name, except whatever we are defining in the when condition, when statement, then populate with unknown. That is the default value. Then transform the df, and finally show this data. So you can see this. So you can use your when condition, otherwise for populating the default value very easily, like this. Here you can see it has populated. Wherever it found India, then it populated this country code column with the in value. For the remaining, this is not understanding because this was not mentioned in our when condition. Then this is populating simply unknown. Now the same you can do with simple SQL query also. Or here we are completely working with the data frame API. We are not working with the SQL one. But if you relate the query with the SQL, this query is very much similar to the SQL one. If you are having the understanding there, simply you can call out the same. You can relate it here. Then you have another one. Union by name. So you can do the practice example with union and union by name, union all and all. Have anyone used union and union or union all in their real-time use case? No, no issue. So this union by name. Union by name combines two data frames with the same schema but different column orders. Column orders can be different, but tables should be with the different, same schema. Otherwise, this is going to be fail. So this union requires column to be in the same order in both data frames. If you are, so these are the different. This is union. Then union by name. Columns are matched by name regardless of order. Order is not required. It can be in any order. If you're using union all, then in Python it is same as union. So union and union all is same. In SQL, that can be having some different. Okay. So for union, if you are calling, you can have in interview also you can have a question, how I can merge two data frames. So if merging is coming in the picture, then maybe your question can relate to union, either union or union by name. Okay, let me take this one as example.
One question, I think in SQL, union removes the duplicate. Union all.
Sorry, can you please come again?
In SQL, if you are using union, I think by default it removes the duplicates. So see, that's why union all is faster. Is that the case in DataFrame also?
In data frame, union and union all is same.
Same. Yeah, okay.
This is not having any different behavior. Okay, so here let's take one by one. Actually, in Spark, what happens? It will, if you are using some function today, tomorrow you may get, okay, this is deprecated. You may get that warning. A time to time, they will be doing some enhancement and they will be deprecating the previous one. So most
Or like
of the
in
time
new
you
version,
are,
yes.
correct. So most of the time, as of now, you are having union that you can use. But union and union all, that's the very common use case in SQL side. Whenever you have the requirement with multiple tables or multiple output uh, from the different queries and you want to merge the output data, output or directly merging the tables. So let's say this is the example where we, okay, Spark session already we have, so not required. So this is the data frame. Okay, data 1 is having this name and this name. Data 2 is having this name and this name. Now the column name. Column name is having name age and name age. Both are having same. Then we are doing df1 dot union df2. Then it should print the output with merging both the data frame. You can, in interview, this is again a very common question, how I can merge both of the data frame. Then you have to clarify that what should be the order of the column, what should be the name of the column, either that should be same or it can be different. And then you can get this in which case that this is how you can merge the data frame. So let's see this first. So if you see here, we get all the 4 records from the both data frame. And now we are having 4 that data frame has been merged. Now let me take union all. Union all is there. Let me run this. And here you can see again same. Ananya, Rohan, Priya, Vivek. And you were asking that it will be removing the duplicate, right? In the SQL. Let me do that as well. I will be keeping the, oh, sorry. I will be keeping same name here. Now let me run this. What you get? You get duplicate, right?
Yes.
So there is nothing. Even I will be copying this in the same data frame, just to try. So in Spark, um, both are having the same definition, same implementation. There is no difference. If you see here and an 3 time now, that means there is no impact regardless of the duplicate, the drop duplicate means this is simply not checking the distinct one. Okay. And let me remove the duplicates. Now this is the union. And then we have mismatched the order. Let's say this was for matching the order where your name and age are both data frame is having same column name and in the same order. Next, let's take that another one. If you see this, Ananya, and this is having name and this is having age. And this is having city and this is having name. Means name is common between both, but this column is different between both, right? City and the name. And again, the name order is not in the same. Here name is the first column and here name is the second column. Now create a data frame where name and age and then city and name. One column key is there, but in the different order and two different column names are there. Then how you can do that? Then union by name with missing column handling. Here you have one option also for allow missing columns. Either you want to make it true or make it false. We will see that both. Here I'm saying union by name. Let's run this. And what you say? Name, Ananya and Priya. For age, wherever this data was not available, this populated null. For city also, this was not available for the one data frame. This then did null. But it has did the merging, right? Data was merged regardless of same column name order. It worked. It worked by the union by name because this is specifically looking for the name. And based upon the name, this is doing the merging. Let me make it false. Now we will run this. What it is having. Cannot resolve column name, age, amount, city, and name because this is looking for the age column while when it is trying to merge. And you are saying allow missing columns false. That means this will not be working with the condition if any column is missed. So if you think that you have two data frame, their orders can be anything that is not in the same order and there can be some different columns, but still you want to merge, then you have to take this key, okay, this parameter, and you have to make that true, then that will get enabled. Wherever that column is found, it will be populating the value. Whenever that is not found, that will be simply populate null for that, as we already seen like that. Then this is the use case for union by name, where that will be particularly focusing on the name and not on the order. Then let me comment out this as well and then next move to next. Okay. And then let me uncomment this one as well. Here you can see data frame with mismatch column already we seen that. Okay, this is the different use case. So let me do this, otherwise this will be kind of mess up. Now you have again same example. You have name and age, you have name and city. Data frame one with mismatch the column. Okay, here data frame one has name and age. Data frame two has name and city, and add missing columns to the align schema. You have two options. Either you go with the previous example where we said allow missing columns, and for the missing columns simply this is giving none, means a null value. And if you do not want to do that, if you want to handle manually, then before merging, you are going to populate with column city, add the city column in this one and add age column in this one. Then both are having the matching column name, and then you can do the union. Then whatever lit means literal value. Literal value, it can be anything, means a default value. Okay, you are going to populate. Which one is easier? What do you think between both? Missing allow value and this is the manual step just to merge this kind of data frame. Here if you add missing column, so once you did the addition, then this is coming with a name, then this is the age, then Priya, Bangalore, and name, age. What is your thought here? Which one is easy? The previous one or this one? No idea. Union df equal to df1 aligned, df2 aligned, then run this.
I think this leak used in real projects also. I have seen somewhere.
Right. In
Yeah.
real project, this will be most of the time. That's why I am focusing on this. So the thing is, you can have, let's say you are getting two input data from the source, okay? And finally, your requirement is to merge both the data. There can be exact same schema. If exact same schema, then simply you can do union without any single thought, right? It will be doing. But another thing can be exact same schema but in different order, then you can say union by name. Then that will not be looking out for the same order. It can match with the name. That is fine. And again, there can be a condition where either same schema, some schema is similar, some schema is different, but you want to merge. In that case, what you want, what you can. One thing is either manually you add all those missing columns in both of the data frame and match, make both to match, right? Then you can do the union like here I am doing. I am adding I am simply adding the column. So simply if you add the column here, like you are means simply you are adding the column city, you are adding the column age. How many columns you have? You think that okay, data frame 1 is having missing column city, then you are adding that. Data frame 2 is having missing column age, then you are adding that. Like that, you can have multiple missings. So first you add the missing column, then you do the merging with the union. That is one thing. And second thing is, don't do anything. Simply use this allow missing columns true. Then no need to handle this manually and all. Whatever is missing, that will be getting populated with null. Whatever is not missing for any of the order, means regardless the order, that will be getting match, and it will be getting the matched output. Means your data frame will be merged without checking out for the ordering and all. Okay.
Yes, but I think real life should not be the case. Nobody.
Sorry.
I think real project scenarios, everybody is kind of follow the schemas. At least I think.
No, that they will be following the schema, but what if you are getting from the source file only? Then either you correct at your end or you can handle with this, right?
Yes, yes. Okay,
And
got
you
it.
can correct from your end only if you have few data sets. Let's say every day you are getting some one data set, two data set, five data set, you can do. What if you are getting the data in, let's say this is the streaming data set, you are getting some customer data and all the time schema is having some differentiation. It is having different, and in the day, in a single day you are getting some thousand of the source file, source data, or thousand times with thousand schema, some different schema, maybe little bit also. Then in that case you will not be able to handle manually, right? Of course you can do that. In that case you have to take it up.
Got it.
But this again depends, as you are saying, in the real time. So in the real time, all the companies are having different use case, different data sets, even different frequency for the data. So based upon that, our use case gets defined, right? So this always depends, but most of the time you may get, and you have to keep in mind that if that is the case, how you can. And again, keep in mind that this is a very common question for merging the data frame, how you can merge. Then you have to define what if the main thing is column name should be same, order should be same. Then you are good with union. If column name is not same, or if that is the same but in the different order, or maybe some different column name, then what can be? So both conditions you have to keep in mind and then you can respond. Okay. And then,
Okay.
okay. Fine, then we have one to more transformation, I guess we will cover tomorrow, and then we will start with the next part. Next part in the sense, next use case apart from this transformations, means we have already covered narrow transformation, where transformation will be get covered in first half an hour tomorrow. Then we will be moving the next. Okay, fine. Then anyone has any question, anything?
No, no, okay, thank you.
Okay, fine then. Have a good day. Let's meet tomorrow. Bye.